Okay, so let's set up the basic classification problem before we start talking about model-based classification. So the setup is as follows. You have data points x1 through xn. They could fall in one of k classes, and you're given labels y1 through yn, where each label tells you which, y1 tells you which class x1 is in, etc. Right? So these yi's are in one of k classes, right? So they're in, classes 1 through k, and you're going to use these to train machine f. Right, so f is just a function that when you're given a new data point x, it'll make a prediction on the label y, right? So y hat is f of x is your estimate of the label, and it's also in 1 through k. So basically making a decision on which label that particular data point, new data point you've seen, corresponds to. Is it a cat or a dog? That's what you're trying to decide. So this is an example of what I would call a hard decision, and that's sort of what you want to do at the end of the day. A self-driving car needs to know whether it should stop or not, for example. So you want to do that. But often in the middle, you might want to actually do soft decisions. So what do I mean by that? This is what a hard decision looked like. Now let's look at what a soft decision might look like. You have that data point in there, and you create a machine, and the output of the machine is actually a probability vector that tells you the probabilities that you estimate of the class being 1 or the class being 2, etc., or the class being k, right? And of course, these are probabilities, so they have to sum to 1, right? So of course, this is a more general form than the hard decision, right? Because you can always go from a soft decision to a hard decision by basically saying, I don't know what happened here, so let's stop this for a minute. So when you have a soft decision like this, which is a probability vector, you can of course always pick the maximum out of all these probabilities and make a hard decision like shown here. So many machines that we create are actually structured in that fashion, that basically you spit out these soft decisions and then you make a hard decision at the end of it. And you might want to compare these soft decisions with the labels that you have. So in that context, actually it's far more convenient, instead of thinking of the labels as being, we were thinking of the labels as being from 1 through k. Instead, I can just think of the labels as, these are, soft decisions that I have certainty about. So if y is 1, is label 1, then you can think of it as a soft decision vector, a probability vector, where the first entry is 1. So this corresponds to the scalar y being equal to 1. And so y equals 0, 1, 0, 0, 0 corresponds to y equals 2, and so on, right? So, and this is what's called a one-hot encoding, and we'll see more of this as we go along. But for now, let's just think of the labels as the scalar labels coming from 1 through k, and we'll introduce one-hot labels as and when we need them. So that's the basic setup of the classification problem.